When we look at the moon, we are actually looking at our past, at one of humanity's greatest dreams, perhaps its purest curiosity. For thousands of years, that white sphere was nothing more than a mystery hanging in the sky. Poets gave it meaning, civilizations revered it, and scientists tried to understand it. But in the mid-20th century, this romantic curiosity suddenly gave way to a harsh, cold, and calculated competition. Because the moon was no longer just a celestial body, it had become a symbol of power. Especially during the Cold War, reaching the moon meant far more than a scientific achievement. It was about showing the world who was in charge. The rivalry between the United States and the Soviet Union was not limited to an arms race. Space became the new stage for this struggle. In 1957, the Soviet Union launched Sputnik into space, followed by Yuri Gagarin orbiting the Earth in 1961, both of which were major prestige losses for the United States. From that point on, the issue was no longer just science, it became about being first. And that's exactly why John F. Kennedy set that historic goal. Before the decade was out, a human would be sent to the moon and safely return to Earth. That single sentence marked the beginning of one of the most ambitious engineering projects in human history, the Apollo program, led by NASA. This program was not just about building a rocket, it meant creating an entirely new space transportation system from scratch, sending humans out of Earth's safe environment into a completely hostile one and bringing them back. Even today, it's hard to imagine a project of such scale and speed. At the time, hundreds of thousands of people worked on it. Engineers, scientists, technicians, all focused on one goal, the moon. During this process, the Saturn V was Sassofa's rocket SAS was so the cake was an divided show final of all was beyond the Zuki to buy, and it is still considered one of the most powerful rockets in human history. This massive machine had the capacity to break free from Earth's gravity and carry humans to another celestial body. But the rocket alone was not enough. The real challenge was building a system that could go to the moon and return. The solution they developed still inspires awe today, the Lunar Orbit Rendezvous. In other words, while the main spacecraft orbited the moon, a smaller module would descend to the surface, then lift off again and dock with the main vehicle. Under the conditions of that time, this idea seemed almost like science fiction. And when 1969 arrived, humanity witnessed one of the most unforgettable moments in its history. With the Apollo 11 mission, Neil Armstrong and Buzz Aldrin landed on the surface of the moon. Armstrong's famous words were not just a sentence, they were proof that humanity had pushed beyond its limits. But perhaps the most interesting part came afterward, because contrary to what most people think, the moon landing was not a beginning, it was a peak. Between 1969 and 1972, there were 6 moon landings. 12 humans walked on the lunar surface. Scientific data was collected, rock samples were brought back, and experiments were conducted. But after all these achievements, what many expected did not happen. Humanity did not settle on the moon. No permanent base was established. In fact, we didn't even return. After the Apollo 17 mission in 1972, human flights to the moon came to a complete stop, and over time, this became a major question mark. If we could do it in 1969, why can't we send humans to the moon today? This question began to be discussed both scientifically and socially. Some argued that it was purely economic, and indeed, the Apollo program was incredibly expensive. At the time, a large portion of the US budget was allocated to it. But as the dynamics of the Cold War changed, the need for such massive projects also diminished. Once the Soviet Union was no longer seen as a major threat, the political value of going to the moon also declined. Another factor was the loss of public interest. The first landing created enormous excitement, but subsequent missions did not have the same effect on the public. For many people, going to the moon was no longer new. This reduced politicians' willingness to allocate resources to the program. Combined with costly events like the Vietnam War, continuing the Apollo program became nearly impossible. But there's an even more interesting dimension to this. Over time, discussions about lost technology began to emerge. People started asking, how is it possible that a civilization capable of going to the moon with 1960s technology is unable to do so today? At first glance, this question seems logical, but it is actually quite misleading, because what was done back then was not about building a sustainable system. On the contrary, it was a project focused on a single goal, where cost and efficiency were secondary concerns. Today, space missions are evaluated based on very different criteria. Factors such as safety, cost efficiency, sustainability, and long-term planning are much more important. Still, these explanations were not enough for everyone. Especially with the rise of the internet, countless conspiracy theories about the moon missions began to spread. Some claimed that humans never went to the moon at all. Others suggested that discoveries made that were being hidden. While most of these theories lack scientific basis, they managed to create doubt in people's minds, because there was indeed something strange. Humanity had gone to the moon and then simply stopped. And now, as we come to the present day, a new player enters the stage, the Artemis program. This program aims to return humans to the moon. But this time, the goal is not just to go, it's to stay, to establish a long-term presence, to turn the moon into a stepping stone for reaching more distant destinations like Mars. However, this goal is far more difficult than it seems, because going to the moon remains one of the most complex challenges humanity faces. Radiation, long-term life support systems, economic sustainability, technological safety. When all these factors come together, we begin to understand why returning to the moon has taken so long. But perhaps the real question still remains. Does humanity truly want to go back to the moon, or is this just another matter of prestige? And perhaps most importantly, this time, will we actually be able to stay, or will the moon once again remain just a place we visit? Going to the moon once and then not returning for half a century has been etched into human history as a strange silence. And as time passed, that silence grew heavier because technology was advancing, computers were becoming smaller yet more powerful, rockets were improving, and even private companies were beginning to reach space. Despite all this, the inability to repeat that first great leap inevitably pushed people to consider different possibilities. At that point, the issue stopped being just, why didn't we go back? And turned into a deeper, more skeptical question. Why didn't we really go back? The idea of lost technology became central to these discussions. People began to question this. How could a civilization that reached the moon with the analog computers of the 1960s fail to do it again today? It sounds compelling, even logical at first glance. But when examined closely, this line of thinking turns out to be based on a superficial comparison, because what NASA did at the time was not to establish a technological standard in the modern sense. On the contrary, it was about creating highly specialized, extremely expensive, and non-sustainable solutions for a specific goal. In other words, the systems developed during the Apollo era were not designed for repeated use, but to successfully complete a single mission. For example, the Saturn V rocket was an incredible engineering marvel, but it was also extraordinarily expensive. Each launch cost billions of dollars in today's terms. On top of that, these rockets were not reusable. Today, one of the primary goals of space technology is to reduce costs and make systems reusable. That's why modern rocket designs are based on a completely different philosophy than those of the Apollo era. So, the issue is not being unable to do it, but rather not wanting to do it the same way. Another critical point is the human factor. During the Apollo missions, the tolerance for risk was much higher than it is today. Astronauts faced dangers that would be unacceptable by modern standards. The probability of losing lives during a mission was significantly higher than what would be considered acceptable today. However, in the atmosphere of the Cold War, these risks were deemed acceptable because the issue was not just science, it was national prestige. Today, in human spaceflight, safety has become the highest priority. This makes projects slower, more expensive, and more complex. Even so, all these rational explanations have not been enough to completely eliminate public skepticism. Especially with the rise of the internet, countless theories about the moon missions have emerged. The most well-known of these is the claim that the Apollo 11 mission never actually happened. According to this theory, the moon landing footage was filmed in a studio, and the entire world was convinced by this grand production. Although this claim has been scientifically debunked many times, it is still defended by certain groups. The main reason for this is often not technical details, but psychological and sociological factors. People tend to believe that major events must hide major secrets. But even more intriguing are the claims that go beyond such theories. According to some, humanity did go to the moon, but encountered unexpected things there. These claims usually revolve around the idea of hidden truths. For instance, it is suggested that unexplained structures were seen on the lunar surface, or that astronauts reported certain findings that were never disclosed to the public. None of these claims have any scientific evidence, yet they continue to attract attention, because the unknown is always more fascinating than the known. When we return to the real world, one of the biggest reasons for not going back to the moon is actually quite simple: changing priorities. After the Apollo program ended, NASA shifted its focus to Earth orbit. The Space Shuttle program was launched, and the International Space Station was built. These projects aimed to establish a more sustainable and long-term presence in space. The moon, on the other hand, was left out of these plans, because in the short term, going to the moon did not offer significant scientific returns, at least from the perspective of that era. However, over time, this perspective began to change. Especially in the 21st century, the moon once again became a focal point. There are several reasons for for this. The first is the moon's resource potential. Rare elements like helium-3 are believed to have future applications in energy production. The second is the moon's strategic position. It could serve as a kind of stepping stone for deep space missions. A base established there could make it easier to reach more distant targets like Mars. This new perspective has turned into a concrete objective with the Artemis program. The goal of this program is to return humans to the moon and this time establish a permanent presence. However, this objective is far more complex than during the Apollo era, because now the issue is not just going, but living there, working there, and building a sustainable system. At this point, new players are entering the scene. Not only governments, but also private companies have joined the space race. This increases competition and has the potential to reduce costs. However, it also brings new challenges, because space is no longer just a field of science. It has also become an economic and political arena. Despite all these developments, the process of returning to the moon is progressing more slowly than expected. The reason lies in the inherent complexity of such projects. Everything has to work flawlessly. Even the smallest mistake can result in billions of dollars in losses and cost human lives. That's why processes move extremely carefully and slowly. But perhaps the most important change is happening in humanity's perspective on space. During the Apollo era, space was a frontier to be explored. Today, it is increasingly seen as a place to live, and that fundamentally changes the goals. It's no longer just about planting a flag, it's about building a life there. And that is exactly why returning to the moon is not just a repeat. It could be an entirely new beginning. But what shape this beginning will take is still uncertain, because past mistakes, lessons learned, and shifting priorities all directly influence this process. Perhaps the most interesting part is this. After humanity succeeded in going to the moon, it didn't really know what to do next. That's why it didn't return. But now it seems to have a clearer idea of what it wants to do. And that may mean that this time we could truly stay. Still, the question remains the same. What is different this time? And will that difference really be enough for us to stay on the moon? Although the idea of returning to the moon may sound new today, it has never truly disappeared. It has simply changed form, shifted priorities, and perhaps most importantly, changed meaning. During the Apollo era, the moon was a destination to be reached. Today, it is seen as a tool to be used. This difference reveals just how deeply humanity's relationship with space has transformed, because now the goal is no longer to plant a flag, it is to build a system. One of the most significant initiatives at the center of this transformation is the Artemis program. Named after Artemis, the twin sister of Apollo in mythology, the program symbolically claims continuity, but this time the objective is far more ambitious, not just to go to the moon, but to stay there. The missions planned under this program include first establishing a station in lunar orbit, then conducting regular landings on the moon's surface, and ultimately building permanent bases. However, there's a vast difference between goals on paper and turning them into reality. NASA no longer has the unlimited budget or the freedom to act alone as it did during the Apollo era. Today, space projects require far more international cooperation, private sector involvement, and political balance. This makes the process both slower and more complex. The repeated delays of the Artemis program are largely a result of this multi-layered structure. Another notable aspect is how the space race itself has been reshaped. In the 20th century, this competition was between two superpowers. Today, many more players are involved. China, in particular, has drawn attention with its lunar programs. Its robotic missions, successful sample return operations, and long-term plans for human missions are seen as signs of a new competition. According to some analysts, this indicates the beginning of a new space race. However, this time the nature of the race is different. It is more focused on economic, technological, and strategic superiority. One of the most important differences in this new race is the involvement of private companies. Firms like SpaceX are making groundbreaking advances in space technology. Reusable rockets are dramatically reducing costs, making targets like the moon more accessible. However, this also creates a new kind of dependency. Government agencies now rely on private companies for such projects, which shifts the balance of control and responsibility. A critical component of the Artemis program is the planned Gateway Station in lunar orbit. This station will serve as a staging point for moon landings and provide logistical support for long-duration missions. However, building such a structure is extremely complex. Constructing a space station is already a major challenge, but doing so hundreds of thousands of kilometers away from Earth multiplies the difficulty. At the same time, the bases planned for the lunar surface are a subject of intense discussion. The moon is not as livable as it might seem. There is no atmosphere, no magnetic field, and radiation levels are high. Temperature differences are extreme, and the day-night cycle is much longer than on Earth. All these factors make establishing a permanent presence on the moon extremely difficult. For this reason, planned bases are designed to be largely underground or heavily shielded. At this point, the potential advantages offered by the moon also come into play. The presence of water ice, especially in the polar regions, is one of the cornerstones of these plans. This ice could be used for drinking water as well as for producing rocket fuel. That would turn the moon into not just a destination, but also a resource. If these resources can be used effectively, the moon could truly become a base for deep space missions. However, there are still major obstacles ahead of all these plans: technological challenges, budget constraints, political changes, and international competition continuously influence the process. The repeated delays of the Artemis program are a clear reflection of this. While official explanations often highlight technical reasons, there's always a broader context behind the scenes. And perhaps the most critical question is this: is this time truly different, or will history repeat itself? During the Apollo era, going to the moon was a necessity. Today, it is a choice. This difference could determine the fate of the entire effort, because necessities drive humanity to act while choices are often postponed. If returning to the moon remains merely a prestige project, it may once again be left unfinished, just like in the past. But if it becomes part of a genuine long-term vision, then it could mark the beginning of a new era for humanity. Right now, we stand exactly between these two possibilities. On one side, the achievements of the past, on the other, the uncertainties of the future, and humanity is caught between them. We want to return to the moon, but it is still unclear how much determination truly lies behind that desire. Perhaps that is why the moon is still there, silent, reachable, yet just as distant, as if it is waiting for humanity's next step. And when that step is finally taken, it will not just be another landing, it will be a moment in which humanity redefines itself. But until that moment arrives, the question will remain the same: are we truly ready,